So I wanted to make this video about our new chicken coop door that I just installed outside in our chicken coop. I'll show you a little walkthrough. I'll show you where it's installed and how the chickens use it and how I use it. And it's in conjunction with the chicken feeder that I also have installed out there. All this is powered by solar panels, 2 solar panels that I have installed on the roof. Those connect to one single car battery. Well, it's not really a car battery, it's a solar battery. It came from Amazon a while back. I got it on sale. A frickin' bargain. I think I paid $79 for it, but it's 100 amp hour, so we don't have a lot of capacity there, right? 2 panels, 1 car battery, and then whatever charge controller came with the kit. And then I had to buy an inverter. The kit didn't come with one, so I didn't know anything about solar. I bought the smallest inverter I could. I figured I had 2 solar panels. It allows me to add up to 2 more, but it's a really small system is what I'm getting at. And that powers everything. So I'll have the 110, 120 voltage that my chicken feeder needs, and then I have the 12 volt that I have some lights connected to, and then I now have our new chicken door connected to. And then there's a 5 volt rail out there that I can plug various sensors to, and so we'll go over all that in this video and kind of step through what I did and how I built it, and some of my thought processes and where things went wrong, and kind of the hiccups I had while going through and building this thing, and some of the tools that I used to build it as well. In a minute I'll kind of show you one of the big things, which is the heartbeat of this door is the opener and the closer, and it uses a cycloidal mechanism to reduce the gear enough to where I can actually have enough force to open this thing, hold it open during the wind, and then close it, and not enough force that it will cut my hand off or cut a chicken in half. So but let's go into that next. So 2 years ago I started building this chicken coop, and I'm not quite done with it, but almost. I think we had like 8 of these guys originally, but just the 4 now. Little donkey back there, he's not ours, but I just put these lights in so you turn them on at night. They're on 12 volt. There's my chicken feeder, it's on 110. Panels up there on the roof. And here's the coop. I sleep up there, walk out through there, got a couple windows in here. Solar panels come in through there. I need to put a disconnect here, a charge controller. And it goes down to the battery. I just got 1 battery right now because that's all I really need. It charges up over almost 100%. I can't get to 100% obviously, but and then I turn the lights on overnight. Well, I had these lights, the front lights on overnight, and it got down to like 87%, so it's not a big deal. 12 volt wire to this little breaker fuse box, and then this distributes to this switch, top switch. Front lights, bottom switch is outside. They're on separate fuses. And then the inverter, I have done some really bad shit, and I plugged it in because there's no lugs on this inverter. It's supposed to be, manual says there are, but there are no lugs. So I plugged it in, and I wired it directly to this. So if someone was to try to plug this into a vacuum or something, it obviously wouldn't work. And so there's really no harm there. You don't want to leave this plugged in, obviously, while you have it wired up. But anyway, I'm going to do that again to a series of plugs over here, I think, or a plug here and then a plug up there so I can hang that heat lamp. And then I'll have to put another battery in here probably, but that's the solar setup. Okay, so we're going to go over the cycloidal drive now, and the arm, so to speak. It's got 1, 2, 3, 4 links really, and so it's a pretty simple deal. We got our first arm right here. It's the big guy, and when it spins, rotates rather, this part kind of stays in the same spot, right, and this part will rotate. And as that rotates, this will also push the door. And so this whole deal rotates this way like this. And it can't really rotate any further because this pin stops here. The door also is kind of wedged. This is in a way it's installed up against the 2x4, won't really allow it. So in all reality, we can't go too far. So I'm not super worried about that mechanically. But let's hide some of this stuff and get into it. The load disc right here connects to that first arm, and it also connects with little screws that don't have threads down here all the way through our cycloidal discs that are for some reason hidden. All right, so there's disc 1 and 2. And so those go through the load discs with these shoulder joints and or shoulder pins, and they have little rollers on them. And these will roll around inside the disc just enough with some tolerance so that when the eccentric cam spins, that these discs will actually wobble just enough around these shoulder joints and allow it to move. So this is eccentric cam will spin, say, 20 times, and this entire disc will spin once. And so let's see if we can hide something. I don't know if I have any animations. Probably not. I'm not even going to bother looking. All I do is slow down the video. And so let's hide this. And so we got some bearings on our cam. And I believe these are 10 by 15 bearings. Yeah, something like that. They're really small bearings. That's what I had to work with. And then we have a bigger bearing right here. I can't remember the dimension on that. 60 by something. 60 by 40 something. Sounds right. But the shoulder pins were probably the most expensive part. The rollers, rather, on those. I think those were like $9.99 from Amazon for a pack. And there's some 5mm pins that you can use right here. I wound up not using them at all because the plastic PLA is really hard. I ran it overnight the whole time just to see what would happen to the motor, the driver, everything, and it got warm, but nothing failed, right? So the drive was fine. There was no melting. There wasn't a bunch of wear. I didn't use any grease, and so I wasn't super concerned about any issues there. But otherwise, there's not a whole lot to this, guys. It's just some cycloidal discs. If I can get the document to load properly, there we go. All right, so we're loaded. Let's see, got our load disc. Let's hide the casing. So you can kind of see that they're just wobbling in there. They're not mounted to anything on the bottom. They're just tightened into the load disc, these screws. And load disc looks weird because I came back and made a lot of edits, but that's neither here nor there. And so I can mount it. But you could use basically any NEMA 17 for this particular casing, the way it is. This was designed from a different motor that I had for some, or a different gearbox I had for something else. But that's pretty much it. That's the whole deal. All these parts are really just fittings or hardware. So use this cycloidal profile generator if you want to make these. You can use either the offset or some kind of scaling to get your tolerances just right if it doesn't work for you the first time around. I think I had to get like 6 different discs printed before it actually worked, but that's the whole deal. All right, so this is the test rig for our chicken door that we just printed. It's a little tight right now. The motor's not too back drivable, and it's got a little bit of slop right now that I'm trying to fix. So I'm 3D printing something to help fix some of this slop that I actually have in the door. And I know it's not from the motor itself. It's something to do with these 2 linkages. So I'm printing a different piece with a different orientation. This is going to be a little further down to give us a little more leverage because we're already using the same leverage here. We're really just screwing ourselves by bringing it back this way, the way that this works. So we're just going to turn it into a 90. And I don't think I'll have to reprint this. I might.
but using these holes that we already have with these pieces here, I think I can just reprint this piece and make this arm shorter. And so we're going to try that out. But I'm going to show you what I'm talking about. So it's powered up. Got a little screen quickly made so that we can connect to Wi-Fi and check the time. Let's see if that does that. Ooh, it's taking a long time. Sync time. Taking last thing. All right, there we go. We got time. It's a little slower than normal. So I'm just going to try to open the door. And I'm going to show you what happens when I press open. And this is what we're trying to fix. Something's getting in a bind there. Right? It just popped open. And I can reset home and open again. Right? And it works once it's open. But we're going to have some issues moving forward with this guy getting in a bind. And you can tell that it kind of gets in a bind when I have anything in the way at the bottom. So we're going to have to improve some clearances here around the door outside. This is a test frame. It's a little smaller than the one I have outside. And so I have some room to bring this up. And this frame is a little wider than the one I have outside. So I can actually move this motor back as well to give myself a little bit more, I guess, play if anything does bind up. But just trying to work through some of the issues here. I've had some issues with the code as far as maybe having too much going on at once for this MCU to be able to do. I've had this in the past with other projects, but I'm asking it to do too much in the way that I'm doing it. So I'll actually go over through some of this when I do a video on the code. I'm going to try to do a complete video on all 1,500 lines of code that I'm using to make this work. And that goes between this ultrasonic sensor, controlling this motor that's driven by this driver here, and just reading the sensor. It's really not controlling the sensor so much, but we're sending signals and getting signals back. Outside of that, most of this is just power distribution. We're really not doing anything else other than controlling the door and connecting to Wi-Fi for time and controlling the door based on that time that we got. And that's basically the whole project. This could all be done on a really small PCB and just kind of housed in the back of the screen to make this thing simple. But I had all this stuff just sitting in a box ready to be used. It's perfect. I didn't have to buy a single thing for this project, not even filament. I was using filament that I already had. So everything included in this entire project was stuff that I'm reusing from prior projects. And that was kind of the purpose of this. That's partially why things look a little messy. But there's nothing back here other than these wires connecting to this, and then a USB cord that is routed from our 5-volt bus. And I have a little 2-amp fuse going to that as well. But that's all it does. This 2-amp fuse powers here. I have I think a 1/2-amp fuse going to our 5-volt power for our ultrasound sensor. And then I don't have this driver fused at all. I have, 2.5 total 12 volts coming in, something like that. So I'm not super concerned about this being fused. If anything, the motor might be starved for power. I don't think it is based on what I'm getting out of this door itself, but I currently have it in the quarter step mode and it's working just fine. I could put it in half step mode, but it may be a little weak with the wind, I'm still thinking about things like that. But outside of that, this project's fairly simple. I'm going to try to actually reduce the code length before I really talk about it. And then I'm going to consider putting an electromagnet right here in this door that I turn on with a relay. And so it'll literally just shoot something into this little locking hole that I have here and then pull it out when it's time to open the door, etc. And so I need to get just about everything right before I do that. And that could be done with the servo as well, but I want to build a magnet. So that's pretty much the whole project. All right, here's the countdown. 10:59:40. The door should try to close at 10 p.m. The sonar is measuring the threshold distance accurately, exactly. That's the Perfect measurement with the tape measure. Oh my gosh, right at 10 o'clock. And it didn't get hung up. Perfect the first time. Let's open it.
Stop it, Mommy.
See if it lets me open it. Is it locked? I'm gonna try to close it and see if it gets stuck when I put my hand in the way. Uh-oh. What happened there? Let's try that again. I did not get stuck. My hand was in the way. Yeah, obstruction. That's whenever I put my hand in the way, the screen should show an obstruction or a distance. Okay, so we're getting something. It's not perfect, but just close it. Oop. All right, worked that time. Should retry on its own without me doing anything. All right, so something's got to really be there. Just gonna retry. Let's let it get started. I'm gonna put a cup there. Let's move it. Let's say the chicken's here. Uh-oh. It's gonna close on the chicken. All right, it'll close on the chicken.
It'll close on the chicken?
Back to the drawing board.
All right, so I installed the panel right here next to all my solar stuff. Installed the door on the other side of this plexiglass right here. Just kind of ran the wires, and I had to use an extra cable for my motor. Wasn't a problem, but I had to use an extra cable here as well. When I plugged the extra cable in, I don't know if you can see, the screen started acting funny, right? So I have to get my multimeter out here and see if we're getting voltage all the way to the sensor. And then I need to check out the pins on the little PCB I soldered to make sure nothing broke loose. I'm likely going to have to get just solid wires that run the whole way without any connectors. I thought I could just use some stuff I had, but I mean, oh well. It still closes. It will scare off a chicken. Better stop it just in case. Functions just fine. The chickens use it though, so we'll get back to this and fix it. Boom, 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 boom. So here's the chickens actually using the door. Hey, don't let a doggy in. Let's see if she does it. She's gonna do it. Watch out for that guy. You gonna go through too, bud? All right, Zoe. Come on. Oh. It's okay. I know you like the chicken. All right, I'm out here in the coop, and I'm going to try to fix the ultrasound on our little door opener here. I made this cable out of an old vacuum cord and soldered this DuPont cable to this male DuPont cable to the ends. And on the other side, we have some like breadboard header pins. I don't know if you'll be able to see that, but anyway, so I'm gonna plug this in and try to see if I can get it working. All right, so that's working, and I just want to show this again. This is easily the easiest, simplest touchscreen. I spelled Verneuil door controls wrong, but easily the simplest user interface I've ever made. All right, so I'm going to show you the ultrasound working again.
if I can, if you can read it backwards. But we are now registering a stable number, 34.3. So we got that fixed. I'm going to tap the close button and then put my hand in the way. Let's see if it... It's closing. Oh, nice. I'm gonna just try to throw some shit, throw some of this stuff in front of it. So that stuff won't fuck with it. I think we're good. So aside from that last malfunction, I'm really happy with the door. It's got a beautiful appearance. It functions just like I wanted it to. And the only upgrade I think I want to do is add an electromagnetic lock right there. So outside of that, the Cluckworks chicken door is ready to go. So I don't know if you've seen the Cluckworks smart feeder yet, but it's a chicken feeder I made with a CYD cheap yellow display. Has a ESP32 and a TFT touchscreen all in one, so it's really easy for small projects. And so programmed a sweet little UI. It has a few pages. You can put in some settings, some calibrated, like do you have grain feed or do you have a pellet feed? Is it a big pellet, a small pellet? Things like that. Do you want to custom calibrate it? Do you want to feed once a day, twice a day? Do you want to feed every 3 hours, every 4 hours, every 6 hours? And so you can put all these kinds of things in. But when you plug it in, it automatically connects to local Wi-Fi. And all you have to do, you plug it in the first time, there's a local portal. You'll click the launch local portal button, and that's pretty much it. You go on your phone and you'll connect to this feeder IP right here, put in your Wi-Fi credentials, and you're connected. There's really nothing that different than connecting to your local Wi-Fi. So you're connected to Wi-Fi, it's gonna connect to your time automatically. You can find that here in the settings. And after that, we got our time, and you're gonna pick what time you wanna feed them. So what's our schedule? Let's say I feed once a day in the morning. So I just enable the automatic feed with this button right here. And then I choose what time I want to feed them. I feed them at 6 o'clock in the morning, and I feed them half a pound between the 4 birds. That's plenty to have waste. So some days there's extra, some days there's not. But I have a setting in here for feed 2 if I wanted to feed them at night. I don't have it activated, but if I want to feed now, I could feed them from 1 second to 35 seconds right there. And that would pretty much empty the whole bucket right now. I don't have it completely full, so I'm not going to click that. But here I've just got layer pellets selected because it works just fine for me. I've calibrated it in the past, and it's pretty easy. We won't go over that, but you select your flock, how many birds you have, the average weight of them. I have some tiny little 12-month Polish, so they're really small, but 2 pounds right here. So ultimately they're just getting a half pound a day from this. It's calculating, I think, an 1/8 pound a bird or something, a little less than that maybe. But on our home screen we have how full our bin is. I just filled our bin here yesterday, so I can reset that right here with the load bin button, and you'll notice the bar is all full now. And I'm gonna go ahead and run now just so you can get a good shot of it. But that spits out a pretty good amount.
So one of the issues I'm having with the solar out in the chicken coop is the inverter power loss to some degree. On days like today, super sunny, there's no issues. It's gonna, charge all night till 7, 8 o'clock, right? And then I'll have plenty of battery to last all night, even if I want to run a fan or a bulb on half power or something like that, a heat lamp bulb. In addition to the 12-volt lighting that I already have running the coop, so I can keep all that running. The only problem is that if I want to charge my chicken feeder, I have to physically go out there and turn the inverter on. And if I leave all of that stuff that I talked about running, the lights and the inverter, then I have a dead battery. And then it takes like a full day to get it going again without anything on. So it takes basically 2 full days of solar if I kill the battery. And so I'm trying to avoid killing a battery. So one thing that they sent with the solar kit when I bought it 4 fucking years ago on Amazon was this Renogy little remote switch, right? And so it's a wired remote switch, and all it is an on-off. But I took it apart and I tried searching Google. I couldn't really find anything. I saw like one dude like 4 years ago trying to do something, and honestly, it was way above my head. So I'm gonna try to figure out how to tap into this with a relay and an ESP32 and build ourselves, I guess, a remote switch. And then all my other ESP32s have no problem catching Wi-Fi out there in the coop. So we will maybe we can just rig this up to plug into one of the other ones I have out there. Probably not the chicken coop one because it's in a really sealed enclosure. The other one I have access to the new chicken door. I might have 2 or 3 GPIO pins available, and I think I only need 1 for the relay. So I'll probably make a video about that next, and that's what I'll do to continue out the chicken coop series. In addition to the electromagnet that I haven't really started ordering parts for, so it'll be maybe another couple weeks on that one, but stay tuned. Thanks.